In this video, I want to talk about types of boundary conditions. And for that, let's consider our schematic of a 1D problem where we had two types of boundary conditions defined. Okay, so let's write the first type of boundary condition where we have a displacement defined at x is equal to 0 to be 0 and displacement at x is equal to L is some prescribed displacement UP. This type of displacement based boundary condition is called Dirichlet boundary condition. And Dirichlet boundary condition is generally defined on the primary field variable, and that primary field variable is our displacement u here. So I can write down that it is defined on the primary field variable. Okay. In a special case to the mechanics problem, we can say that this type of boundary condition is a displacement boundary condition. If you were to deal with a heat transfer problem, then it would be a temperature boundary condition. So remember that it is defined on the primary field variable. Okay. The second type of boundary condition I want to consider is a traction from boundary condition. Okay. So in our case, we have defined at x equal to L, and traction is defined as some prescribed traction. And this falls under a category of Neumann boundary condition. So as you have seen, in Dirichlet boundary condition is defined on the primary field variable. The Neumann boundary condition is defined on the secondary field variable. And secondary field variable is simply the partial of our primary field variable with respect to the spatial coordinate x. Okay, so in this case it will be partial of our displacement u with respect to x. Okay, an example of such Neumann boundary condition is our traction boundary condition, where if you take in traction, which is simply the component of stress in the given direction, right, which is equal to our elastic modulus times the strain, which is elastic modulus times the partial of displacement with respect to x. So now we can see how the traction boundary condition is essentially a Neumann boundary condition. Okay. Now note that we can only have either two displacement boundary conditions or one displacement plus one traction. Okay, and this is specific to this case, right, for 1D. But we can never have case C where both the boundary conditions are traction boundary conditions. Okay, this is not allowed, and you can try to see that by deriving the analytical solution of our differential equation. Okay, and that will turn out to be of the form u of x equal to some constant c1 x plus c2 if we have assumed the force to be 0 and under steady state. Okay, so in order to solve for such constant after integrating our partial differential equation, you will see that if you just had the traction boundary conditions, which is in terms of our derivative of the u with respect to x, you will only find values for the constant c1 and never get the values for constant c2, and then your solution will always have that unknown, and this interestingly represents a rigid body motion. Okay, so to take away from this lesson on boundary condition, we can always have either two displacement boundary conditions defined or a combination of a displacement and traction boundary conditions, but never only traction boundary conditions. Okay.